matrix of a system is shown below. Find its KCL equation. Here these are the node numbers 1, 2, 3, 4. There are the currents I1, I2, I3, I4. Okay, if the current is entering the node, we are taking it as a -1. If the current is leaving the node, we are taking it as a +1. Okay, now at node 1 the KCL equation is I1 minus I2 is 0. At second node I3 minus I4 equals to 0. At third node minus I1 minus I3 plus I4 equals to 0. At fourth node I2 equals to 0. So if I2 equals to 0, see, if these are the four equations we got. Now I2 plus I3, it is not a KCL equation, and I3 plus I4, it is also not here. So the only possibility is option B, hence option B is correct. Calculate the dV of 0 plus by dt in the circuit shown below. Here Vc of 0 minus, that is V, is nothing but Vc of 0 plus is 5 volts. Okay, then Vc of t is nothing but 5 e power minus t by RC. RC is the, for source free circuit it is going to be 10, that is e power minus 0.1 t. Now dVc of t by dt is nothing but minus 5 into 0.1 e power minus 0.1 t. So at t equal to 0 plus dVc of dt is nothing but minus 0.5, that is volts per second, which is option B is correct. Calculate the voltage drop across the dependent current source is shown below. See, we have to take the KCL at this node. Okay, node here. So minus 2 plus 2i1 plus Vx by 4 plus Vx by 4 equals to 0. I1 is Vx by 4. So 2 is nothing but Vx by 2 plus Vx by 2, that is Vx. So Vx is 2 volts. Hence option D is correct.
Areas are connected by a tie line as shown below, with V1 is greater than V2. Okay, he has given V1 is greater than V2 and delta 2 is greater than delta 1. Then which of the following statement is correct? Okay, if you see active power P, it is sensitive towards delta. Okay, whereas reactive power is sensitive towards voltage V. Okay, if you see here V1, let us talk about first active power. Delta 2 is greater than delta 1. What does it mean? That power angle in area 2 is greater than power angle in area 1. Now what is the direction of flow of active power here? From area 2 to area 1. So active power is transferred from area 2 to area 1. So option 2 is correct answer. Okay. Now similarly, if you see reactive power, okay, V1 is greater than V2. What does it mean? That I can say V1 minus V2 is equal to drop in the line. Okay, here there is drop in the line. So what I have to do here, I have to inject reactive power in bus 2. Okay, that means area 2 needs reactive power injection. What happens if reactive power injection area 2 takes place? V2 will be increased. If V2 is increased, V1 minus V2, that is drop will be less. So area 2 needs reactive power injection. So 2 and 4 is the correct answer. So option D is correct.
Generator is supplying 50% of maximum power delivered to infinite
bus bar. Suddenly the load on the generator is increased to 75% of the maximum power delivered. Due to this, rotor is subjected to oscillations as shown in figure. Okay, this is the figure he has given. Now we have to find whether the generator is stable or unstable, and about delta 2 and relation between delta 2 and delta maximum. Okay, now what is delta naught here? Delta naught is equal to sine inverse of 1 by 0.5. So this is 30 degrees. Okay, now what about delta max? Delta max is nothing but, okay, let us take this as some delta 1. Okay, what is delta 1 here? Sine inverse of 1 by 0.75. Okay, so 1 by sine inverse of 0.75, this is equal to 48.6 degrees. Now what is delta max? Delta max is nothing but 180 degrees minus the generator operating at new point. New point angle is 48.6 degrees. So this is equal to 131.4 degrees. But what he has given, delta 2 is given as 132 degrees in figure. Okay, now what does this mean? That, see here, this delta 1 is the new power delivered. Okay, maximum of he has given increased to 75%. Okay, now what is delta max? Delta max is the maximum angle at which rotor is stopped, or that is equal to 131.4 degrees. If you increase beyond this angle, that is delta 2 is equal to 130 degrees, the rotor is not going back to the new operating point. Okay, because this system is unstable system. That's why this system is unstable system, because rotor cannot go back to its new equilibrium point, that is delta C. Okay, so this system is unstable as delta 2 is greater than delta maximum. Okay, if this system, let us take, if you got this delta max angle as 130 degrees, then what does it mean? That 130 degrees, that is, let us take the delta 2 is around operating at some 120 degrees. That means the rotor can go back. The accelerating area should be equal to decelerating area, so that rotor is going back to the new equilibrium point. But here the angle he has given as 132 degrees, that means rotor is not going back, that our decelerating area will not be there here. So the system is unstable as delta 2 is greater than delta max. Option B is correct answer.